Hello everyone. So recently I just uploaded a video today actually that where I talk about how I have to change my algae hormone experiment. Well, that requires having to dilute my stock solution to an even lower solution because I only need, for the next experiment I'm doing, I essentially need 1 microgram for one of these vials here, or centrifuge tubes, so per 15 milliliters. And there's no way I can actually measure that amount properly to be able to do the experiment. But if you dilute a stock solution that you have from one concentration to another to a lower concentration, you can get to that lower microgram level. And for me, for right now, I currently have indole acetic acid stock solution, which is at 0.285 moles of concentration. My goal is to be able to add my new solution at 30 microliters to one of these tubes, and that be able to carry the roughly 1.7 micrograms of solution of indole acetic acid. Well, to do that, I need to dilute my 0.285 mole solution down to 3.3 times 10 to the negative 3 moles. Now, to do that, I need to do a dilution calculation. And what I'm going to do is I'm actually going to show you how to calculate it, and I'm going to calculate it right here while I do it. So there's a formula that you use, and it's V1 times M1, M means molarity, equals V2 times M2. So essentially it's now V1 is what we're looking for. It's the volume of the original substance or the original solution that you need to transfer to a new container to get your proper concentration. The M1 is the concentration of your original solution, which in this case is 0.285. Now the V2 is the total volume, which is in this case it's going to be 50 milliliters. So it's the total volume of new solution. And M2 is the desired concentration of the solution. So what I'm going to do is I'm going to replace the variables. So you have V1 is the unknown right now, so we'll keep that down there. M1 is 0.285, and then V2 is 50 milliliters. The desired moles is 3.33 times 10 to the negative 3. Now, first, what I'll do is I'll calculate 3.33 times 10 to the negative 3 times 50 milliliters. And what that gets me is roughly 1.665 moles. Now, on this side, we'll just move this down. So V1 times 0.285. And then now we want to get the V1 by itself. This is, pretty much just regular old algebra. And to do that, we divide both sides by 0.285. So now what we do is on the left side, we have V1 equals, and then this, when you calculate this out, it comes out to 0.58421, and then it continues on. Now this is where significant figures matter. The smallest significant figure is the 0.285, so it's 3 significant figures. So essentially we're going to round to 3 significant figures, which is 584, because the 2 is, rounding is lower than 5, we can say that it's 284. So the result is 0.584 milliliters. And what that comes out to is 584 microliters. And now that's what I'm going to do now. I have my 50 milliliter bottle, and I have my distilled water, and what I'm going to do is I'm going to take the indole acetic acid at mole concentration of 285 or 0.285. I'm going to take my pipette and I'm going to set it to 0.584 milliliters. Then I'm going to put the 50 milliliters of water in there. Roll this around just in case, just to make sure nothing is settled, even though it shouldn't, but 584, just double checking. Can't exactly reverse this if I don't do it right. I have my 584. Now I put it all the way into the water, and then I push it all the way, and then what I do is I actually bring it back and forth. Let's see if you can see that. I bring it back and forth a couple times, and what that does is it allows as much of the hormone to that might be stuck on the side of the pipette tip to mix in with the water. And then now I get the vortex mixer. Mix it up. Put this one away. And then I'm going to put this in here for now, because I need to print out a label and label it, but I don't want it to sit out in the light for too long. Well, I'll do that after. And anyways, that's how to calculate the dilution factor of when you're going from one solution concentration to another. Thanks for watching, and make sure to hit the subscribe button and all that good stuff, and watch my research. Thank you.